This is chapter 3, Shocking Electrical Secrets. Okay, so what is electricity made of? Hands up, who knows? Huh? Me! Oh dear, it looks like Mr. Sparks, the science teacher, knows the answer. Electricity is a range of phenomena deri- de- derived from a form of energy associated with static or dynamic charges. Charges may be characterized as positive or negative in relation to the number or electrons in a charged substance. Well, thank you, Mr. Sparks. Anyone understand that? No? Okay, let's try again. Everything in the universe is made of tidbits called atoms, and most atoms are surrounded by a cloud of even smaller blips of energy called electrons. The electricity in your power sockets is actually made of moving electrons, and the power of electricity comes from the force of the electrons to give out. Let's imagine an atom as a family. Okay? Mom is the center of the atom family. Everything revolves around her. Actually, scientists would call her a nucleus. The electric kids whiz around Mom. Each electron constantly gives out its energy as an electric force. Quick science note. Actually, the nucleus also gives out an electrical force. You can find out more about both forces in page 26. Bet you ever know. Electrons are really tiny. An electron is 10,000 times smaller than the nucleus. If you have a very steady hand, you can put 1,000 billion electrons in a line, and even then, you wouldn't have quite enough to stretch across a pinhead. Got a torch? Alright then, switch it on and start counting. 1, 2, 3. That dim, feeble light in your torch bulb uses 6.28 billion electrons every second. Just to give you some idea of how massive this number is, a school day is about 23,400 seconds. If you don't believe me, try counting them. So if you wanted to get to a million, you have to count non-stop for another 10 days. If you kept counting for another 32 years and 354 days, that means counting while eating and sleeping and going to the toilet, you'll eventually reach 1 billion if you hadn't died of boredom. Not gobsmacked yet? Well, get this. In order to count these electrons used by your dim and feeble little torch in just 1 second, you should have started counting well before the Earth was formed 4,006 million years ago. What we call an electric current is actually a stream of electrons flowing through a wire. This is measured in amps. Can you imagine what it would be like to swim in the stream? Here's a story about a person who did just that. He's an odd job worker called Andy Man. Good name, eh? It all began when Andy got a shrinking feeling and was made to feel very, very small. Oops. This photo was taken while he was still microscopic. There's a clear one in the next page. Quick warning, Mr. Sparks is threatening to test you on the science of electricity after this story, so you better read it very carefully. Here's me story, and I want cash up front, okay? Me name is Andy Man. Andy by name, handy by nature. Get it? Okay. You can call me anytime, but not when there's stars on the telly. Yeah, I was telling you what happened. It all started when I went down to Professor Bazov's house to do a job. Just a bit sanitary engineering, as we say in the trade. Well, she had a blocked toilet pipe. Anyway, imagine me surprised when she said I had to wear this protective suit. Alright, I say, thinking the toilet might be a stinker, as we say in the trade. It was an elementary error of identification. When Andy Man appeared, I thought he was Dr. Manning, a visiting scientist who had volunteered to help me with my newly invented shrinking ray. Dr. Manning, the prof told me to stand under this machine. It didn't look much like a toilet, as I was about to say that the wiring looked a bit dodgy, and did she want to see when she flicked the lever. Then she started to getting bigger, and the room started getting bigger. But hold on, it was me getting smaller. Well, I know me card says no job too small, but this job was looking, well, a bit too small. So I went shrinking until I got sucked into electrical wire. Why am I here? I asked myself. There was a malfunction in the diminisher unit. By the time I managed to deactivate the ray, Andy had shrunk to 0.000000025 millimeters, almost as small as an atom. And to make matters worse, he had vanished inside the machine. Obviously, this was a situation of some danger. Yes, well, it was dangerous, alright. The first thing I saw was these weird balls, and I thought, blimey, they're atoms. And there was these tiny blips buzzing around the atoms. They were so fast they looked like a blurry mist. Well, the prof later said they were electrons. The wire looked like this huge tunnel with atoms around the sides, and there was electrons flowing through it like a river. Then I got swept away by them. Electrons. They were like rubbery peas, and I had to swim my life. Was I scared? Yeah. I was wetting myself. How do you get out of this electric current, Andy? Well, me being a skilled electrician, I knew that an electric current is made by electrons all flowing one way, and those electrons were fast. Luckily, they missed me, or I would have been killed until I was dead. Fascinating. The electrons were zapping at 1 million meters per second, and electrical signals can zip along at nearly the speed of light. Meanwhile, I frantically tried to reset the shrinking ray to make Andy bigger. I switched the on the light to help me see. Yeah, well, guess what happened? The wire got narrower. All the electrons squashed together, and they slowed down and started rubbing against the atoms around the sides. Yeah, and me. Phew. It was hot. Well, it is friction, isn't it? Rubbing makes heat, like when you rub your hands together. Blobs of light started flying around. Then it hit me. I was inside the light bulb. Yeah, the one she just switched on. Mind you, I wasn't feeling too right. Of course, I didn't know that Andy was in the bulb. We scientists call it the friction, and it describes resistance. And the blob of light Andy saw are called photons. They are given off by the electrons as they try to cool down. It must have been a significantly fascinating experience. Yeah, fascinating, Prof. Shame I was about to die. Me protective suit was melting, and I reckoned I'd be melting soon. I was boiling hot and sweating buckets. This is Andy, I, I said to myself. I'll never get to see the Darts final. Just then, my mobile rang. I didn't feel too chatty, but I answered anyway. Might as well say goodbye to someone. I observed Andy's business card and remembered he had a mobile phone. So I called his number. I was shocked to discover that he was inside of the light bulb and switched it on immediately. The switch stopped the flow of electrons and the light went out. Just in time. The wire started to cool down, but I wasn't out of the woods yet. Out of the wire. How was the prof supposed to get me out? Maybe I was going to stay tiny all my life. How was I supposed to live? I couldn't even go outside because a man might tread on me and squash me flat. It took me 3 hours to enlarge the ball wire into small steps, and each time I cut out the portion of wire that contained Andy until eventually he was free. Then I was able to enlarge them back to its correct size. Of course, he was rather annoyed. I was fuming. First she sticks me in a light bulb and nearly cooks me. Then she brings me back to my old size. Exactly, not 6'2". I always wanted to be 6'2", didn't I? And guess what? She only goes about that bunged up toilet, and then I really blew a fuse. Just wait till she sees me Beetle. That won't be tiny. I bet she wants to shake away then. A quick note. Good news. We managed to lock Mr. Sparks in the stationery cupboard, so there won't be a science test. Phew. But just in case he managed to escape, here's a quick sheet with all the science test answers. Okay? Watch. Watched? Okay, let's get on. Shocking expressions. Do you know any good conductors? Do you say, well, there's my music teacher, but she's a terrible conductor. That's why the school orchestra is so bad. No. No. A conductor is a substance that lets electrons flow through it. Metals are good conductors because many of their outer electrons are free of their atoms and flow around anyway. And that's why electrical wires are made of copper metal. Okay? Right now, you might be bursting to ask a question. Well, I don't know that for sure. You might be bursting for a pee. Anyway, your question might go like this. If electrons are so small, how were they ever discovered? Well, why not discover the next electrifying chapter and find out? One of the most amazing things about science is the way scientists calmly tell us tiny things exist even though no one has ever seen them. Well, let's face it, they're both far too tiny to see even with the most powerful microscopes. But here's the amazing story of how it was discovered. That's the electron on your teacher's brain. Two really big breakthroughs. By 1880, scientists knew how to make it and they knew how to store it. See page 55. But they didn't know what electricity it was actually made of. In that year, scientist William Crookes built a new machine to help them find the answer. Cathode ray tube. Okay? Okay, quick scientific note. By taking the air out of the container, Crookes was getting rid of atoms in the air that might get in the way of the invisible ray. We now know that the ray was in fact a stream of electrons shooting out from the battery. Could you be a scientist? So what do you think made the green glow? A. The glass glowing as it hit the electrons. B. The glass tube glowing where the electrons hit it. C. A chemical reaction between the gas and the chemical in the glass. Answer is B. Of course, Crookes didn't know all of this and he didn't understand what he was seeing. And as you're about to discover, it was hard for Crookes to explain his work to other scientists because they didn't trust him. The problem was that, like most scientists, Crookes believed in ghosts. Here's the story. Crookes was the oldest from 16 kids. Obviously, this can drive a person to desperate measures, and maybe that is why Crookes became a chemistry teacher. But eventually, he inherited a fortune. He retired from teaching and set up his own private chemistry lab for exciting experiments. But some of his investigations shocked other scientists. In those days, many people believed that the spirits of the dead came back as ghosts and could be summoned by people with special abilities called mediums. Crookes decided to find the truth by careful scientific observation. Tonight, I set up an experiment with medium Florence Cook. I had heard of her reputation for making ghosts appear, but nothing was to prepare me for what I saw. We sat in a dark room, and the medium went into a trance. Her eyes closed, and she started to breathe quickly and deeply. "Is there anyone there?" she called out. There was a silent rap on the table. "Rap one for yes," demanded the medium. "Are you a spirit?" "Can you make yourself visible?" I asked, sounding rather scared. A cold wind blew through the room. The curtain fluttered, and I saw a vague white shape blinked in horror. It was a woman with a ghostly pale face. She drifted around the room, and I almost managed to touch her unhurriedly form. What are you?" I gasped. The ghost moved her pale lips. In a faint voice, she replied, "My name is Katie. I have a message for you." The medium gave a sudden cry. She was pale and sweaty now, and when I looked again, the ghost had vanished. So what was the message? I can't wait for the next session. But had he seen a real ghost? Crookes' fellow students were less than impressed with his work as a spectre. Most scientists don't believe in ghosts. and they thought that crooks didn't stand a ghost of a chance of proving anything. Instead of the investigation, ruined Crook's image as a sensible scientist. One scientist who didn't give up on crooks was John Joseph Thomason, a professor at Cambridge University. JJ, as his friends called him, was useless at experiments and usually broke his equipment. Luckily for JJ, when he became a professor, he had people to do the hands-on work for him. JJ thought the ray crooks had reported might be made of tiny blips of energy, and to find out more, he repeated one of Crook's tests of using a magnet to bend the ray. He worked out how strong the magnetic force had to be to bend the ray, and using complicated maths, he calculated the weight of the blips that he thought made up the ray from the angle, and it was bent. Try doing that for your math homework. It turned out the ray was made of tiny blips, and they were far lighter than the lightest atoms. Thomason calculated how much energy each blip carried and realized it matched the lightest atoms. Thomason reckoned rightly that each atom carried at least one, and usually far more, of the blips. The tiny blips, of course, were electrons. Electrons made things feel solid. You see, the electrical force made by an electron pushes other electrons away. Solid objects are made of atoms and electrons tightly packed together, so when you squash them, they push apart slightly, and this makes the object feel solid. Just think, if it wasn't for electrons, sitting on a chair would be like sitting on a slimy school dinner. Blancmange. You sink through it and end up sprawled on your bum. Electric forces can do lots of other interesting things. They can even make your hair stand up and you can find out how in the next chapter. It is bound to set a few sparks flying. Thank you, everybody. Today will be the 2 days and we'll be here. Tomorrow I'll do 2 chapters as promised. Be sure to stay here. Bye.